Hello students, in today's class we are going to learn about the next conic section, ellipse. So before we get into ellipse, I wish to give a quick recap about the parabola which we learnt in the previous class. So what is meant by a parabola? Parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point. It is the collection of all points which is equidistant from a fixed line and a fixed point in the plane. This collection of all points is called a parabola, right? And this fixed line is called the directrix. The fixed point is called focus, and the line perpendicular to the directrix and passing through the focus is called the axis, and the point of intersection of the parabola with the axis is called the vertex. These are all the things which we have learnt already. And we have seen the four standard equations of parabola: y square equal to 4ax, y square equal to minus 4ax, x square equal to 4ay, x square equal to minus 4ay. Right? When it is along when the axis is along x-axis, we will have y square equal to. When the axis is along y-axis, we will have x square equal to. Right? So when y square equal to, when the axis is along x-axis, we will have the curve either open rightward or leftward. When the axis is along y-axis, we will have the curve either open upward or downward. Okay? All the standard equations of parabola are arrived at certain conditions. What are those conditions? Focus is on the coordinate axis, vertex is on the origin, and directrix is parallel to the other axis. So under these conditions only we have derived the standard equations of parabola. And we have learnt what is meant by latus rectum. What is meant by latus rectum? It is a line segment perpendicular to the axis through the focus and whose end points lie on the parabola. It is a line segment perpendicular to the axis through the focus. It passes through the focus and the end points lie on the parabola is called the latus rectum. What is the length of latus rectum of a parabola? Which is 4a. We have seen how we got all these values in yesterday's class, right? Then I have tabulated all the values of the four standard equations for the better remembering purpose, right? So when the equation is y square equal to 4ax or minus 4ax, the axis is along x-axis and the focus is a comma 0 or minus a comma 0 accordingly. When the focus is a, directrix is going to be x equal to minus a, right? When it is along x-axis, the focus will lie on x-axis. When it is along y-axis, the focus will lie on y-axis. When the focus lie on x-axis, y coordinate will be 0. When the focus lie on y-axis, x coordinate will be 0. You can remember in this way. In all the cases, vertex is going to be 0, 0 and latus rectum is going to be 4a. Right? These are all the things you have to remember. So based on these inputs, we have done few problems. Now in today's class, we are going to learn about ellipse. Now we are going to see what is meant by an ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. See, if you take a point on the ellipse, its distance from two fixed point, the sum of the distance will remain same. The sum of the distance will remain same. The sum of the distance will remain same. Then the collection of all those points will form a ellipse. So an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. Right? The constant, which is the sum of distance of a point on the ellipse from two fixed points, is always greater than the distance between the two fixed points. We will call these two fixed points as the foci, plural of focus. For parabola, we have only one focus, but for ellipse, we have two focus. So, plural form of focus is foci, F-O-C-I. F-O-C-I, foci, right? So, ellipse has two foci, F1 and F2, two fixed points. right? So it is given that the sum of the distances is always greater than the distance between the foci. Okay, the midpoint of line segment joining the foci, the midpoint of line segment joining the foci is called the center. The midpoint of line segment joining the foci is the center, right? Then which is called a major axis? The line segment through the foci, the line segment through the foci, this is called the major axis. Then which is called a minor axis? The line segment through the center and perpendicular to the major axis is called the minor axis, right? Then which are called vertices? Which are called vertices? Vertices are the end points of the major axis. End points of the major axis. Then we will denote the length of the major axis as 2a. Length of the major axis as 2a. Length of the major axis as 2a and length of the minor axis as 2b. So if this length is 2a, if AB is 2a and we know O is the midpoint of AB, then automatically AO will also be A, OB will also be A, right? And hence the coordinates of A and B are given as 0, A and 0, minus A, and hence the vertices are 0, plus or minus A, because this is our y-axis and this is our x-axis, right? A point lie on x-axis is denoted by 0, some constant. This is positive side, so 0, A, and this is going to be 0, minus A. So the vertices are 0, plus or minus A. What is A? A is the length of the semi-major axis, or else 2A is the length of the major axis and 2B is the length of the minor axis. Then what is the distance between the foci? The distance between the foci is 2C. Distance between the foci is 2C. Okay. So as I told you now, length of semi-major axis is A, because the length of the entire major axis is 2A, therefore semi-major axis is going to be A. Similarly, length of semi-minor axis is B, right? So far what we have seen the definition of an ellipse. What is the definition of an ellipse? The set of all points in a plane such that the sum of whose distances from two fixed points in a plane is a constant. And always the sum, the constant, is greater than the distance between the two fixed points. These two fixed points we will call it as a focus, we will call it as foci, and the midpoint of the line segment joining the foci is nothing but the center. Then we have seen the line segment joining, the line segment passing through the foci is called the major axis. The line segment passing through the foci is called the major axis, and the line segment passing through the center perpendicular to the major axis is called the minor axis. The line segment passing through the foci is called the major axis. The line segment passing through the center perpendicular to the major axis is called the minor axis. Then length of major axis is 2a, length of minor axis is 2b, distance between the foci is 2c. Okay, these are all the things we have seen so far. Now we are going to see the relationship between A, B and C, right? What is A? A is semi-major axis, B is semi-minor axis, and 2C is the distance between the foci. If the distance between the foci is 2C, how will you give the coordinates of the focuses? This is going to be 0, C, and this is going to be 0, minus C, right? As the vertices, because we know the distance between this is 2C, therefore the coordinates are, they lie on the x-axis. So 0, C, 0, minus C. This is 0, A and this is 0, minus A. Similarly, this is going to be the coordinates. These coordinates you can give because this is your minor axis, right? So its coordinates, how will you give? B, 0 and minus B, 0, because it lies on the y-axis, right? See here, we told you the length of the major axis is 2a. Therefore, this is semi-major axis, right? So, this distance is going to be a. This distance is also going to be a. Similarly, we told the length of the minor axis is 2b. Therefore, this distance is going to be b. This is also going to be b. And we told the distance between the two foci is 2c. Therefore, F1O is going to be c and OF2 is also going to be C. These things you should know. Now we are going to learn about the relationship between A, B and C. Right? What is the relation between semi-major axis, semi-minor axis and the distance of the focus from the center of the ellipse? The relationship between A, B and C is A square equal to B square plus C square. This also you have to remember. Now how we can find this? Now take a point P at one end of the major axis. Take a point P at one end of the major axis. Then since this point is on the ellipse, we know that sum of the distance of this point from the two foci will be equal to, which remains constant, right? Now PF1 plus PF2 can be written as F1O plus OP plus F2P. Why? See, we are going to, since the point P is on the ellipse, we are going to find the distance between, the sum of the distances between the point and the two foci. So, PF1 plus PF2. Now, PF1 we can write it as F1O plus OP. PF1 can be written as F1O plus OP and F2 we have written as such. Right? And what is F1O? F1O is nothing but C. And what is OP? OP is the semi-major axis, which is nothing but A. What is F2P? F2P we can write it as A minus C. This full distance is A minus C. Alright. So if we simplify, we got it as 2A. C will get cancelled. So A plus A is 2A. Similarly, take a point Q on the end of the minor axis. Then again we are going to find the sum of its distances from its two foci. So QF1 plus QF2. Right? What is QF1? QF1, this is perpendicular we know. Therefore, we can go with Pythagoras theorem. We know this is B, this is C. Therefore, QF1 is going to be square root of B square plus C square. Similarly, this side is also square root of B square plus C square. So, it is twice B square plus square root of B square plus C square. But we know since P and Q are the points on the ellipse, the sum of the distances from the point to the foci should remain constant. That is what the definition of the ellipse. Therefore, we can equate 2A equal to twice square root of B square plus C square. If we simplify, we get A is equal to 2 will get cancelled. We got A is equal to square root of B square plus C square. So, A square is equal to B square plus C square. This is the relationship between A, B and C. That is a semi-major axis, semi-minor axis and the distance of the focus from the center of the ellipse. 2C is the distance between the foci and C is the distance between the focus and the center. So, what is the relation between semi-major axis, semi-minor axis and the distance of the focus from the center, which is A square equal to B square plus C square. This you should remember, right? Next, we are going to see some special cases of an ellipse. What is some special cases of an ellipse? We are going to check out some special cases based on this condition. What will happen if C equal to 0? If C equal to 0, both the foci merge together because C is the distance between the center and the focus, right? And if C is 0, 2C will also become 0. Therefore, there will be only one focus. F1 and F2 will coincide each other, right? In that case, if we put C equal to 0, we will have A square equal to B square. We will have A square equal to B square, which means A equal to B. When the minor axis and the major axis becomes equal, the ellipse will become a circle. Yes or no? Only there is a difference. If everything becomes equal, then it will become a radius. If all the distances are same from a fixed point, it will become a circle, right? Since it differs, we have it as an ellipse. If A and B both are same, it is going to be an circle. So when C equal to 0, which means the distance from the center to the focus is 0, then the two foci will coincide and hence it will become a circle. What is the second special case? When C equal to A. When C equal to A, what will happen? We will get B equal to 0. When C equal to A, B will become 0. Therefore, there won't be any minor axis at all. It will become only a straight line segment. Right? It will become a line segment F1, F2 joining the two foci. So, these are the two special cases of an ellipse. Right? Next, we are going to learn about another concept of ellipse, which is called eccentricity. What is called an eccentricity? Eccentricity of the ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse, which means E is C by A. What is E? E is C by A. We denote eccentricity by E, and E is C by A. The ratio between one of the distance from one of the foci to the center divided by one of the distance between one of the foci and to one of the vertices of the ellipse. So C by A. Alright. Eccentricity is C by A. Now we are going to learn about standard equations of an ellipse. What is a standard equation of an ellipse? X square by A square plus Y square by B square equal to 1 and X square by B square plus Y square by A square equal to 1. If the major axis is along X axis, then its equation is written as X square by A square plus Y square by B square. If the major axis is along Y axis, then its equation is expressed as X square by B square plus Y square by A square equal to 1. Yes, so these are the two standard equations of ellipse. As we have seen 4 standard equations of parabola, we have 2 standard equations of an ellipse based on its major axis. Now let us see how we derived at this equation. Now let F1, F2 be the foci and O is the midpoint of the line segment and O is the origin, and the line O through F2 be the positive x-axis and through F1 as the negative x-axis. Let the line through O perpendicular to the x-axis be the y-axis. Then let the coordinates of F1 and F2 be minus C, 0 and C, 0. Now we have chosen a point P on the ellipse such that the sum of the distances from P to the two foci be 2a. We have assumed the sum of the distances as 2a. Pf1 plus Pf2 is equals to 2a. Now using distance formula, we can find what is Pf1 and Pf2. What is distance formula? Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So the coordinates of P are x, y and coordinates of F1, F2 we know. So if we add these two, which is equals to 2a, right? Now bring this term to the other side and squaring on both sides and applying a plus b the whole square identity, we have obtained a square root of x minus c the whole square plus y square is equals to a minus c by a x. Okay. Now again squaring on both sides, we will get x minus c the whole square plus y square is equals to this whole square. On further simplification, we have arrived at x square by a square plus y square by b square equal to 1. Hence, any point on the ellipse satisfies this equation, right? Here we have used the condition for c square, a square minus b square, because we have derived that relation already. A square is equal to b square plus c square. As we did for parabola, on the other hand, if p of x comma y satisfies the equation, then we are going to check whether the sum of the distances is 2a or not. If it satisfies, now we have chosen an arbitrary point and we have arrived at the equation. Conversely, we are going to check whether it is true or not. So let p of x comma y satisfies this equation. Then y square can be written as b square into 1 minus x square by a square. Now let us find PF1 and PF2. Instead of y square, we have substituted this. What is PF1? Distance formula, right? Instead of y square, we have substituted this and we obtained some value, and similarly PF2, and we have added these two, we got 2a. So both the ways it is true. Hope you got it. Initially, we assumed PF1 plus PF2 is equals to 2a and we obtained the equation of an ellipse. Now we have to check, right, because it's our assumption. We have taken the sum of the distances is 2a. Now conversely also, if it becomes true, we can give a concrete thing that it is an equation of an ellipse. So conversely, we are assuming if it satisfies the equation, then what will happen? We are going to check the sum of the distances, right? So conversely, we have checked, we have arrived at 2a only, and hence the standard equation of an ellipse with center at origin and major axis along the x-axis is x square by a square plus y square by b square equal to 1. Alright, if the major axis is along y-axis, then the equation is x square by b square plus y square by a square equals to 1. Next, we are going to find the latus rectum for the ellipse. What is latus rectum? Latus rectum is a line segment passing through the focus and it is perpendicular to the axis. That's what the definition we have learnt in parabola, right? The same thing here for the ellipse also. Latus rectum of an ellipse is the line segment perpendicular to the major axis passing through any of the foci and whose endpoints lie on the ellipse. Right. Now we are going to find the length of this latus rectum, and let us assume the length of AF2 as L. Let us assume the length as L. Then what will be the coordinates of A? C, L. Why it is C, L? Because we know the coordinates of F2 are C, 0. Therefore, the latus rectum passes through the foci. Therefore, it is going to be C, L, since we have assumed AF2 as L. Right. Now if you see, the point A is lying on the ellipse. Therefore, we can very well substitute the point in the equation of the ellipse. What is the equation of ellipse? X square by a square plus y square by b square equals to 1. So instead of x, we can substitute c, and instead of y, you can substitute L. But what is the c? C is nothing but in terms of A and E, AE, because we know the eccentricity is C by A. So what is C? AE, right? So instead of C, we can write AE. AE the whole square divided by A square plus y is L square divided by B square equal to 1, right? So A square will get cancelled. So L square is B square into 1 minus E square. So if you simplify, we can find what is L square. Again, C square can be replaced in terms of C and A. Again, C we know A square minus B square. We need it ultimately in terms of A and B only. So repeatedly apply two results. One is, first we got C. C is AE, and again we have E, right? But E is C by A. So what is C? A square is equals to B square plus C square. So instead of C square, we can write A square minus B square. Right? Initially, if you apply that, the calculation will be little bit complication. That's why initially they have substituted C as AE and then they have applied this. Right? So ultimately we got L square as B power 4 divided by A square. B power 4 divided by A square. Therefore, L is B square by A. Therefore, the length of latus rectum of an ellipse is B square, semi-latus rectum is B square by A. Right? Why it is semi-latus rectum? Because AF2 only we have assumed it as L. What is latus rectum? AB. The full length is latus rectum. AB and CD. The full length is latus rectum. Therefore, length of latus rectum is going to be 2 times L. So, 2 times L is 2B square by A is the length of the latus rectum of an ellipse. So, you have to remember length of the lattice rectum of ellipse is 2b square by a. Hope you remember, length of the lattice rectum of parabola is 4a, right? So length of the lattice rectum of ellipse is 2b square divided by a, right? So far what we have seen, the definition of an ellipse, and we have seen what is major axis, minor axis, which are called vertices, right? Then length of the major axis, length of minor axis. Length of major axis is 2a, minor axis is 2b, distance between the foci is 2c, semi-major axis is a, semi-minor axis is b, and the vertices or the coordinates, if it is along x-axis, it is going to be ends of the, if it is along x-axis, then it is going to be a comma 0 and minus a comma 0. And then we have seen all these things, relationship between a, b and c, a square equal to b square plus c square. Then we have seen special cases of ellipse. If c is 0, it is going to become a circle. If c equal to a, which is a straight line joining the two foci. Then we have seen what is eccentricity. E, it is denoted by E, and it is C by A. It is the ratio between C and A. And we have seen two standard equations of an ellipse. X square by a square plus y square by b square equals to 1, and x square by b square plus y square by a square equal to 1. If the major axis is along x-axis, the coordinates of the foci are c comma 0 and minus c comma 0, right? And the end points of the vertices are going to be a comma 0 and minus a comma 0. These two coordinates are going to be, these two lies on y coordinate, y axis, right? Therefore, ends of the minor axis is going to be 0 comma b and 0 comma minus b, right? And if the ellipse is of this kind, where the major axis is along y-axis, then the foci lie on the major axis only. Remember, focus will lie on the major axis. Therefore, the coordinates of the foci will be 0 comma c and 0 comma minus c, and the end points of the major axis, the vertices, are going to be 0 comma a and 0 comma minus a, and the end points of the minor axis are going to be b comma 0 and minus b comma 0. And these standard equations of an ellipse are derived at certain special conditions where the center is at the origin and major and minor axes are the coordinate axis. And we have seen it is clear that it is symmetric with respect to both the coordinate axis. And already, as I mentioned, foci always lie on the major axis. Remember, whether the ellipse is going to be like this or this, the foci will lie on the major axis only, not on the minor axis. So foci will lie on the major axis. Okay. Then how will you identify major axis is along x-axis or y-axis if the equation is given? Major axis is along x-axis if the coefficient of x square has the larger denominator, right? The major axis is along y-axis if the coefficient of y square has the larger denominator. Using this only you can identify if the equation is given. If the equation is given, how will you identify? If the coefficient of x square has the larger denominator, if the coefficient of x square has the larger denominator, then we can say it is along x-axis like this. If the coefficient of y square is greater denominator, then it is along y-axis. Okay. Then we have seen what is the length of the lattice rectum. Length of the lattice rectum is 2b square by a. So with all these inputs, now we are going to solve problems on ellipse as we have done for parabola. Now we can see how solve problems on exercise 11.3. First question is to find the coordinates of the foci, vertices, length of the major axis, minor axis, eccentricity, length of the lattice rectum of the ellipse. All these things we know. What are the coordinates of the foci? It is plus or minus c comma 0 or 0 comma plus or minus c, it depending on which is on which axis the major axis lies, either x-axis or y-axis. Similarly, the vertices is going to be plus or minus a comma 0 or 0 comma a. That's what we have seen, right? a comma 0 or minus a comma 0, or else 0 comma a or 0 comma minus a, because we know vertices are the end points of the major axis. Vertices are the end points of the major axis. So if we identify on which axis the major axis lies, we can write all these things. Length of major axis is 2a, minor axis is 2b, eccentricity is E is equal to c by a, length of latus rectum is 2b square by a. So if we know what is a, b, c, we can very well give answers for all these things, right? Now let us see how can we solve our first equation. It is given x square by 36 plus y square by 16 equal to 1. So how can we identify the major axis, along which coordinate axis it lies? I told you it depends on the denominator of the x and y. If the denominator of x square is greater, major axis is along x axis. If the denominator of y axis, y square is greater, that is the coefficient of the y square is greater, then it is along y axis. Now in this equation, the denominator of x square is greater, therefore it is along x axis. Therefore the equation is of the form x square by a square plus y square by b square equal to 1. Right? If we compare this equation with this, we got 36 can be written as 6 square and 16 can be written as 4 squared. So the value of a is 6 and the value of b is 4. Right? Kindly don't be in hurry, don't write a is 36, b is 16, because it is of the form x square by a square plus y square by b square. Alright, so a is 6 and b is 4. Now what is the relation between a, b, c? We know c square equal to a square minus b square. Therefore c is square root of a square minus b square. So if we substitute the values, we got c as 2 root 5. Now we obtained all the values of a, b, c. Right? Now we can write all the values. Now what is the coordinate of foci? Since it is along x axis, y coordinate will be 0. So foci are plus or minus a comma 0, right? Sorry, plus or minus c comma 0. Foci is plus or minus c comma 0. Vertices are plus or minus a comma 0. Sorry. Coordinates of the foci are plus or minus c comma 0. So what is c value? 2 root 5 comma 0 and minus 2 root 5 comma 0. Since it lies on major axis is along x axis, it will be plus or minus c comma 0. Vertices are plus or minus a comma 0. What is a value? 6. So 6 comma 0 and minus 6 comma 0. What is length of major axis? 2a. So 2 into 6. Minor axis 2b. 2 into 4. Eccentricity c by a. Right? We know what is c value and what is a value. We can substitute. What is length of latus rectum? 2b square a. We have to substitute. That's it. So we have arrived at the answer. So if you remember all these things, we can mere substitute. If you know what is a, b, c value, we can substitute and get our answer. Right? Now let us move on to the second question. X square by 4 plus y square by 25 equal to 1. So if you see in this question, the denominator of y square is greater. Therefore the major axis is along y axis, right? Therefore it is of the form x square by b square plus y square by a square equal to 1, right? Here the major axis is along y axis, therefore you should compare the equation with x square by b square plus y square by a square equal to 1. So what is the value of b? 2. The value of a will be 5, right? Now we got what is a, what is b. So using a and b value, we can find what is c. C is square root of a square minus b square, because we know a square is equal to b square plus c square. So if we substitute, we can find what is c. Now again we have to list out all the coordinates. Coordinates of the foci are, since the major axis is along y axis, foci will lie on y axis. The coordinates of the foci are, since it lies on y axis, its x coordinate will be 0. So 0 comma plus or minus c, 0 comma plus or minus c, right? So 0 comma c value is 21 and minus root 21 and plus root 21. Then coordinate of vertices are end points of the major axis. Major axis lies along y-axis, so x coordinate will be 0 and it is going to be plus or minus a. So 0 comma 5 and 0 comma minus 5, right? Then length of the major axis and minor axis are going to remain same, 2a, 2b. Then E eccentricity is c by a, length of the lattice rectum. Hope you got it, the difference between the first and the second equation. Here the major axis is along x-axis, therefore the foci and the vertices coordinates, in the foci and the vertices coordinates, y coordinate will be 0. Here the major axis is along y-axis, therefore in the coordinates of foci and vertices the x coordinate will be 0. But remember, foci will have c value and vertices will have a value, right? Hope you got it. The remaining questions are of the same model. Now let us see the 7th question. Here how you will do this problem, you have to divide throughout by this constant because we need equal to 1. The standard form of the ellipse has equal to 1. So you have to divide throughout by this constant to bring it to this form, and then you have to proceed in the same method as we did now in the previous problems, right? So let us see how can we solve the 10th question now. They asked you to find the equation of the ellipse that satisfies the vertices and the foci. So as we did for parabola, now they asked you to find the equation of the ellipse. So to write the equation of the ellipse, we should know along which coordinate axis the major axis lies, either along x-axis or y-axis, that we should know, and then the values of a and b. Then only we can write the equation of the ellipse. Now the coordinates of the vertices are given, plus or minus 5 comma 0 and the foci plus or minus 4 comma 0. And if we analyze both vertices and foci, we know vertices are the end points of the major axis and foci lies on the major axis, and both have y coordinate 0, therefore it lies on x-axis. Both have y coordinate 0, therefore it lies on x-axis. Therefore major axis is along x-axis, right? Therefore we know the equation is of the form x square by a square plus y square by b square equal to 1. Now vertices are plus or minus a comma 0, foci is plus or minus c comma 0. Therefore a value is 5 and c value is 4. Using a and c, we can very well find what is our b, right? Once we know the a and b value, we can give the equation of the ellipse. Yes, hope you got it. The 11th question is also of the same way, but here the vertices are 0 comma plus or minus 13 and 0 comma plus or minus 5. So which clearly tells us it lies on y-axis. Therefore the major axis is along y-axis. Therefore the equation is of the form x square by b square plus y square by a square equals to 1. You have to carefully express the equation, right? And 12th question is also of the same model. Let us move on to the 13th question. Ends of the major axis and ends of minor axis are given, which means this is a comma 0 and this is 0 comma b, right? Ends of major axis only vertices, right? So it clearly tells it lies on the x-axis. Therefore major axis is along x-axis. So from this a and b value are clearly given. A is 3, b is 2. So we can very well express our equation. So in order to give the equation of the ellipse, we should first analyze where the major axis lies, along which coordinate axis, either x-axis or y-axis. We should know that. Then secondly, we should know the values of a and b. If we know these 3 points, we can very well give the equation of the ellipse. If the major axis is along x-axis, it is of the form x square by a square plus y square by b square equal to 1. If it is along y-axis, it is of the form x square by b square plus y square by a square equal to 1. That's it, right? Remaining questions are also of the same method only. If you see the 14th question, here it is along y-axis because x coordinate is 0. So accordingly you have to express the equation. Then 15th question, if you take length of major axis is 26 and the foci is plus or minus 5, 0. So foci will lie on the major axis and it is very clear foci lies on the x-axis, therefore major axis is along x-axis, right? From this we can find what is our C. C is 5 and length of major axis 2a is 26, therefore we can get what is our A. So using A and C we can find B. So using A and B we can give the equation of the ellipse, right? Hope you got it. The same way 16th question, length of minor axis is given, which means 2b is given. So from that we can find what is our B, and foci lies on y-axis, therefore the major axis is along y-axis. So accordingly you have to give the equation of the ellipse. 17th question is also of the same way. Foci is given and the value of A is directly given. So C is 3, A is 4. From the foci coordinates we can identify it is along, major axis is along x-axis, right? And 18th question, B value, C value directly given and they told you foci is on the x-axis. Therefore major axis is along x-axis. Using B and C we can find what is A. Then how to do the 19th question, center is at the origin, major axis on the y-axis. So directly it is given major axis on the y-axis and it passes through the points. So they didn't give you the values of A, B, C. Instead they have given you the 2 points on the ellipse. Now how to solve this? Since the major axis is along y-axis, the equation is of the form x square by b square plus y square by a square equal to 1. Right? So it is clearly given it passes through 2 points. So we can substitute these 2 points in this equation. We will get 2 equations, right, in terms of a square and b square. Now we have to solve these 2 equations. I have taken LCM. So 9a square plus 4b square. I have substituted the x and y value in this equation. X has 3, so x square will become 9. Y has 2, so y square will become 4. Similarly, the other point. So if we take LCM, a square, b square will go to that side. We got 2 equations. Now we have to solve these equations. I have used elimination method. I have multiplied the second equation by 9 and I have eliminated. We got b square equal to 10. If we substitute b square value in any one of these 2 equations, we can find what is a square and hence we can give the equation of ellipse. Right? X square by a square plus y square by b square equal to, x square by b square plus y square by a square equal to 1. Since the major axis is along y-axis. Right? Hope you got it. The last question is also of the same method as we did the 19th one. But here it is given the major axis is on the x-axis. Therefore, the equation is x square by a square plus y square by b square equal to 1. Right? So, with this we came to the conclusion of ellipse. So, I want you to do all these problems as homework. Kindly by heart all the coordinates of the foci, vertices, major axis, minor axis and the standard equations of ellipse, length of the lattice rectum, everything. Only then we can solve the problem. Don't get confused yourself. Only 2 standard equations. Check whether it is along x-axis or y-axis and then give the standard equation accordingly. Hope you got it. Do these problems and post it in the group. If you have doubts, you can ask me. Thank you, students.